Okay, g'day Year 9, welcome to the lesson on angles and lines today. Angles are very important when it comes to navigation and construction and measuring movement. So if you're thinking of any sort of job related to physics, for example, which is a study of energy and movement, it's going to be very important to have a good idea, a good grasp around angles. Also, if you're planning to think about construction, and anything to do with roofs, for example, we've done a lot in senior maths looking at angles and roofs. So that's also a good place to use angles. In Year 8 we looked at angles, and first of all we looked at the accurate use of a protractor to measure and to construct angles. We also looked at naming angles by line segments, noting that an angle has two line rays and they joined at a vertex. So here's our vertex here, and we name that vertex in the middle of the two line rays. Then we had a look at a few different rules. We had a look at the alternate angles, we had a look at co-interior angles, and we had a look at corresponding angles. Now, the idea of alternate angles, it's kind of like a Z shape. So if I were to use the rule to find A, that's kind of a Z shape there. So I could say that A is the same as 110 because alternate angles are equal. The next one was like a U or a C. A number of students said, oh, it's a C, and I can live with that. Now, co-interior angles add up to be 180 degrees. So if I were to look at the magnitude of angle B, I would just say, well, 180 minus that 110 would be 70. So I could say, well, B equals to 70. And then last of all, we had a look at this idea of a corresponding angle, and that was like the F rule. And the rule there is that corresponding angles are equal. They're in the same position, just on different parallel lines. Today, folks, we're just going to review what we did there. So you should also remember that complementary angles add up to 90 degrees. So that means if I have a right angle triangle, and this one's 30, this one's got to be 60 because of the complementary angles rule. Supplementary angles add up to 180 degrees. So if this is 40, that means this is going to be 140. Now, angles at a point or angles at a revolution add up to 360 degrees. So we draw it like this, and if we say, well, if that is what, 160, well, that means that's got to be 200 because they add up to be 360 degrees. We have the vertically opposite angles, so that means they are equal. So if this is 20 degrees, this one's also got to be 20 degrees. Now, when parallel lines are crossed by a transversal, so remember our parallel lines never meet, and the transversal is what crosses the parallel lines. So this is our transversal here and here and here. And we say that alternate angles are equal. So to highlight that again, here's our alternate angles. That's a bit like that Z shape, remember. Corresponding angles are equal. So corresponding is a bit like the F rule. They're in the same position, just on different parallel lines. And co-interior angles are supplementary. That is, what's our definition for supplementary? They add up to 180 degrees. So let's have a look at a few problems, and we'll do them together. So if we want to find the size of an unknown angle, what do we got here? We've got, we know that they all must add up to 180 degrees. So I know that 180 degrees minus that and minus that should equal the value of A. And so 180 take 51 take 23 is 106, and therefore that's the value of A. Now if we got to angle C, so what do we know? We know C. So now we've got to just note that we've got a variety of different angles there, so you need to select the right one. So if angle C is equal to 41 degrees, name its alternate angle. Now remember, that's the F rule, isn't it? So same position, just on not the Z F rule, it's the Z rule. Get it right, Mr. Beasley. So it's the same, it's just on the opposite side of the transversal on the other parallel line. So I'm looking at this one, sorry folks. Corresponding angles are the same position on opposite lines. So we know that they are equal. So the one that corresponds to, which is alternate to C, is F, and therefore F equals the same as C, which is 41 degrees. Now let's have a look at the size of the unknown angles. And we can work through a variety of different ones. So let's have a look, first of all, at what's going to be easier to do. So we've got A, that, and that. We know that C equals B. What else do we know? We know that A plus B must equal 90 degrees. And we know that A plus C plus 90 degrees, because of this right angle here, should equal 145 degrees. What else can we consider? We can also consider that A plus B and that 90 degrees equals 180 degrees. And let's have a look at C first of all. We also notice that and 145 degrees is on a straight line. So I think we might attack that one first. So let's have a look at C. We can see that's on a straight line. So to find the value of C, what we're going to do is just going to say, well, I know that C plus 145 degrees must equal 180 degrees. So we just say, therefore, 180 degrees, take away 145 degrees, must equal 35. And that's what C equals. So let's now have a look at B. We know that C equals B. And so we just say, well, B equals 35 degrees. And we might just write the symbol like that. So we'll just say, well, that's a vertically opposite angles are equal symbol. And let's have a look at A now. So where is A? We know that A and B equals 90 degrees. So we know the value of B, so we just say, well, 90 degrees, take away the value of B, which was 35 degrees, equals A. So 90 take 35 is 55. So we say that A equals 55 degrees, and we just write this right angle symbol with a line through it to say that it's a complementary angle, and that's our working. So what I would like you to do now, folks, is to work on the mastery questions from 5A and then rate your learning, please.